Alright, for our next problem on complex numbers, we're going to find an equation whose solutions are 1 plus or minus 2i. Now, the smallest such equation would be a second degree. That is, it has two solutions. And it makes sense that they are complex conjugates because complex conjugate roots are always in pairs. So, the way we do this is we look at the solution to any quadratic, which is x minus one root and x minus the other equals 0. Now, instead of being real numbers like we're used to, we're going to put these in as complex numbers. So we have x minus 1 plus 2i and x minus 1 minus 2i. Now we multiply this out. First we need to deal with some negatives. So this is x minus 1 minus 2i and x minus 1 plus 2i. Now we can multiply these out, or we can use a FOIL table. So we have x, negative 1, negative 2i, and then x, negative 1, and 2i. So now x times x is x squared, negative x, 2ix. Negative 1 times negative 1 is 1. Negative 2ix. Negative 1 times negative 2i is 2i. And negative 1 times 2i is negative 2i. Then negative 2i times 2i is negative 4i squared. So some of these things cancel out, namely the 2ix and the negative 2ix, and then negative 2i and the 2i. So what we're left with is an x squared minus 2x. Now we've got a 1, and this number right here, I squared, if you recall, is negative 1. So negative 1 times negative 4 is positive 4. So 4 and 1 is 5. Referring back to our original, we now have that the solution is x squared minus 2x plus 5. Sure enough, if you plug that into quad form, you get answers of 1 plus or minus 2i.